Hi guys, are you able to, are you set? Are you able to hear me? Just quickly give it in the comment whether you're able to hear me or not. Yes. Guys, can you hear me? I think you're able to access the chat, right? Is there anything we're missing? Yeah, cool. It seems there is a delay, a significant delay rather. Okay, fine. Great. So there is slight delay in the live session actually. I mean, streaming is having a delay. Okay, cool. So without spending a lot of time on any other discussion, let's directly dive into the topic. Okay, so KPTCL, I think all of you are aware of that. KPTCL, you are here that for that PYQs. I want you to answer the questions very quickly. The questions are going to be very simple. Okay, so I think you'll participate well. uh, yeah, let's see. Hope for the best. Are you ready for the first question? Are you ready for the first question? Circuits, electrical circuits, previous year questions for KPTCL. That's what we're going to see now. Okay, and I want you to answer to the questions. Okay, I want you to answer the questions immediately the moment you got it. And there is a timer. There is a timer here. There is a timer here. There is a timer here. Okay, timer is running. So you have to catch up to the timer. Okay, yeah. Let's move to the first question. Timer is already running. What's the answer? Work. Very good evening, Kaushik. Question is on screen, right? Focus on the question. Question number one. Just answer quickly. Okay, we got some answer. First answer by Sobhdeep. Ravi. Kaushik is A. Muhammad is D. Okay. Abhinav is D. Vignan is D. B. Okay. Just read the question and understand which of the following is true with a series circuit having resistors of different values. Yeah, you got just 16 seconds more. Kennedy Bihari, come on. Yes, very good evening, Mohan. Time's up. Time's up here. Yes, the answer is those who are saying D is answer. Yes, that's an answer. All of the above. See, it is very simple. It is asked for a circuit, series connected circuit. Okay, series connected circuit having a resistors of different values. When you have a circuit with resistors connected in series, suppose this is a circuit. Okay, I have 3 resistors connected in series. Then total resistance of the circuit is sum of all the individual resistances. Yes, this statement is true. The current through each resistor is same. Absolutely. Simple question, right? And current in series circuit, current is same. And option C is the voltage drop across each resistor depends on the value of resistor. Voltage drop V is equal to I into R. Whatever the current is flowing, current into the resistance value. Okay, so voltage is proportional to the resistance value. So option C is also right. All of the above. Okay, here most of the cases I'm giving. Okay, whenever you see all of the above in the question, most likely that will be an answer if you have all of the above in the options. Okay, if you have none of the above in the options, most likely none of the above won't be the answer. Okay, most likely you can take this probability. Okay, so I think we got it. Most of you guys got correct answer. Let's see how we'll go with the second question. Okay, now just create your own question here. What if you have in parallel? Okay, if you have a circuit with resistances are connected in parallel, then what's going to happen? You just take that case and derive the possibilities. Okay, I'm moving to the next question quickly. Yes, timer is also running. Which of the following waveforms has the lowest form factor? Yeah, try first. Just quick formula for form factor. And what is the form factor value for sine wave? What is for square wave? What is for sawtooth wave, triangular wave? Look for the possibilities. Okay. So those who are watching rebroadcast, suppose you can answer with the question number 2, and option, whatever the option you're feeling, you just give it in the comment. Okay. That's also okay. If you're watching live, that's fine. Oh, Mohan is very nicely elaborated. Parallel resistance, all the resistance of the voltage will be equal. Absolutely. Current will divide inversely proportional. Current division will be inversely proportional to the resistance in case of a parallel. More resistance, less current. Okay. Yes, Nagendra, you're absolutely right. RMS value by average value. Okay. Yes. Time's up. So here, the objective of recalling these questions is, suppose you got this first question. When you look into this first question, it's not just you'll think about only series circuit. You'll also have to think about the parallel circuits as well. What will happen to the parallel circuits? What is a voltage division rule? What is a current division rule? What is a KVL? What is a KCL? Try to recall all those things. That's how things will work. Okay. When you're doing these PYQs, you have to recall all related concepts as well. Okay. And if you want mock tests for KPTCL for different subjects, subject wise or complete mock test is available in our app. You can just go to you can download the app and appear your tests. Okay. Let's come to this question. As you have absolutely said, Nagendra said, form factor formula is RMS value by average value. That's what the form factor. Now tell me, what is a peak factor formula? What is a peak factor formula? Yeah, quickly. What is a peak factor formula or a crust factor formula? Yeah. Yes, it is peak value by, or maximum value, you can call peak value or maximum value by RMS value is a peak factor. Okay. Now coming to this, RMS value by average value is a form factor formula. Okay. Now what is the value of form factor for sine wave? For the sine wave, what is the form factor? Yes, it's 1.11. For sine wave means here, you may think RMS value and average value. For a sine wave, average value is 0. For a sine wave, average value is 0. So this will be infinity. That's what one would consider normally. But what we take instead is not just directly average value of this sinusoid. What we have to take the rectified form. Full wave rectified output you should take, and you should consider this rectified output average value when you're finding out the form factor. For any AC quantity, if you want to find out the form factor, we know it's AC quantity is having average value 0. But if you want to go for a form factor, then you have to go for full wave rectified output. Okay, that's why you're getting here 1.11, because RMS value is what? RMS value for this sine wave is root 2 times of Vm. Okay, if it is a voltage, it's a voltage maximum. If it is a current maximum, it's fine. Now, average value of this sine wave is how much? Yes, tell me. 2 Vm by pi. 2 Vm by pi. Okay, now do this operation. Oh, sorry, this is not RMS value, is not root 2 times of Vm. It is Vm by root 2. Okay, yeah. So once you do this, you will get sine wave form factor is this. Now for a square wave, just look at the shape. Square wave shape is like this. Okay, here you have to take again rectified form. Once it is rectified, you will have, suppose maximum value is, once you take a rectified form, this is a rectified form. Okay, it's like a DC value. So RMS value as well as average value will be same for the DC, constant DC. I mean, for a constant DC, average value as well as RMS value just the same, So here this is 1. Here this is 1. Now tell me, what is the significance of this form factor, and what is the significance of this peak factor? Why do we have to go for this form factor and peak factor? Why? Just for the sake of syllabus? It is in the syllabus, that's why we're discussing about this form factor. Or is there any physical significance of this? Yes, absolutely there is a physical significance of this. Otherwise, we don't have to go for it. Tell me, what is that significance? Tell me, for peak factor, what is the significance? Why do you need to go for peak factor? It is to give the rating. When you're designing something, what should be the rating for deciding the rating, or for deciding its voltage withstand capability, for deciding its insulation levels? Suppose I am saying I have a 230 volts supply. Which means what? It's not that the device what I am designing will have experience maximum of 230 volts. No, not that case. When I said 230 volts means what? RMS value is 230 volts. But the device will get to experience root 2 times of 230 volts as a maximum value. So you need to design the equipment at least for this voltage if it is a sine wave, if the input is sine wave. If input is square wave, if it is a 230 volt RMS, the maximum value it will experience is also 230 volts. Okay, look at the square wave. RMS value for this as well as average maximum values, both are same. Okay, now coming to the form factor. Form factor will tell you the significance is how close is the given signal towards the DC, of course, a rectified form. Okay, how close is a given signal close to the DC quantity? Okay, that's why all the time when you go for form factor, and power electronics mostly go for this form factor aspect. Okay, anyways, coming back, so here for this value it is 1. For a sawtooth as well as triangular, can you tell me what is that value? What is that value? For a sawtooth waveform, what is a form factor value? Tell me quickly. Yeah, do you remember? Yes, it is 1 point. For both the cases, it is 1.15. For both the cases, it is 1.15. So, as per the question, it is asked for the lowest form factor value. So, answer is B, which is a square wave is having the lowest value out of all these given waveforms. Okay. Shall we go further? Yes, absolutely, Subadeep. You're absolutely true. Capacitor voltage, high value. Okay. Yes, true. Okay, then we're good to go to the next question. Great. Now it's your turn to answer. Timer is running quickly. Okay, you need to answer quickly. Don't just guess. Of course, sometimes once you try first, then you can go for a guess. Educated guess, not a wild guess. Okay. Okay, Nilgun is saying, why sir insulation design based on the peak value? Because peak voltage, what is why you'll go for insulation design? Tell me. Insulation design itself is based on how much voltage it will, at the max it will experience. Even for that voltage also, it has to withstand its insulating capabilities. Okay, you designed actually 230 volts only. You designed to withstand just for 230 volts, but the input is the voltage what you're giving is 500 volts. So the insulation will break down. The insulation will not be able to withstand. Okay. Yeah. Okay. Mercury, somebody saying, and then again there is also saying the reason because copper is 98. Okay. Bokia, we know this saying A. Everybody is saying mercury. Okay. I think almost all gold is more conductivity compared to copper. Let's see what is the conductivity of all these. Okay. Time's up anyways. So let's see the conductivity of all these. Mercury. What is the conductivity of mercury? It is 1.02 into 10 power 6. Okay. This is the conductivity of the mercury. Yes. See, these are all conductors, some part of conductors. Okay. Normally we use copper as a good conductor. Okay. It must be having good conductivity. Okay. Now silver, yes, it is also having a better conductivity. Gold is also a conductor. Yes. Okay. Let's see the conductivity of silver. The silver is having conductivity of 6.3 into 10 power 7, which is highest of the list what is given. Okay. Out of all these, highest is the silver. Okay. Now copper, tell me what's the copper? Is silver better than a copper? Yes, absolutely. Silver is much better than a copper. So copper is having 5.96 into 10 power 7. So slight difference is there. Now we ask, sir, if silver is having a better conductivity, so why don't we go for a silver instead of copper? I think you know what's going to happen if we go for silver conductors. If you go for a silver conductors, you will see the conductor today. Just after two hours, maybe the conductor won't be there because silver is stolen already. Okay. Even for copper, it used to happen. I don't know whether you hear this in news or not. Copper conductors are stolen. All these things must have come across this. So, anyways, so coming to the gold. What about the gold? Gold is 4.1 into 10 power 7. So out of all these, definitely copper is the cheapest of all. That's why we prefer to go for copper beam rather than going for a gold or silver. Okay. Now coming to the question. The question is, which one is having a lowest electrical conductivity? So out of all these lists, this is the one which is having the lowest. Okay. Not of course, it is insulator. I'm not saying mercury is insulator. Tell me, where do you use mercury in our electrical engineering? Where do you use this mercury as for driving some current or something? Yeah, tell me. I want you to answer for this. Do you know where we use this mercury? Somewhere in transformers, during Buckholes relay. Yes, mercury switch. Yes, mercury is there. Okay, that's what mercury. Anyways, shall we go to the next question? Next question. Yes. I think this most of the people will answer. Most of the people will answer this. Yeah, by the way, did you like the videos? Did you like the session? Quickly like the session, give it a thumbs up. Give it a thumbs up to the session and share the session with your friends so that I'll be coming up with more such sessions in the upcoming days. Okay? Yes, in Transformers Relay, Madhu are absolutely true. Prithviraj, Suman, Kaushik. Yeah, very nice, very nice. What is the electrical charge of one proton? Now, the one who answered it correctly, can you tell me what is the electrical charge of an electron? Proton is over. What about the electron? For electron, what is charge? For the neutron, what is charge? Neutron, I think, neutron, the name itself says. Yeah. I think some people are answering still B or something. Okay. See, you have to give me a tip. You have to tell me a tip so that everybody can remember this, because it's quite natural. It's a memory based thing. It's not a logic based thing. You need to remember this somehow. So I want you to give a logic to remember the answer to this. Yes, answer is absolutely true. This is the answer. Even it is one proton or maybe one electron, the answer is this. What if it is asking for mass? If it is asking for a mass of a proton, tell me what is the answer for that. Mass of a proton would be 1.675 into 10 power minus 27 kilograms. Okay. Now mass of the electron will be how much? Electron mass will be, yes, 9.104 into 10 power minus 31. Yes, charge of neutron is absolutely zero coulombs. Today is my first day here in the live session and it's really fun. Okay, let's have more fun. Okay, did you like it? You're having fun. Did you share it? Great. So anyways, coming back to the question. The question is how to remember this. Now I want you to give everyone the tip to remember this answer. Some people are saying minus 12, some people are saying minus 10. Okay, I want you to give a tip to remember this entire thing. How do you remember? At least somehow, suppose you remember 1.602, but how do you remember 10 power minus 19? How do you remember that? Okay, by the end you can think of that and give me some good logic to remember. Okay, so that I'll share to everybody else. Okay, shall I go to the next question? Yes, let's go to the fifth question back. It is a simple one. Do it. Let me go to the comments meanwhile. Neutron is 0, Kaushik. You're absolutely true. Yes, Nagendra. What is the answer? Nagendra, what is the option you're picking? Current same for series means what's the answer? 15? There is no such option in the options. We don't have 15. A, B, D, none of the above, is it? D. Let's see. Okay, time's up by the way. Let's quickly have a look at what is asked. Consider a circuit with 4 10-ohm resistors and a battery connected in series. Quickly connect it. Don't just try to bring it in the midair. Quickly just connect it. You have 4 10-ohm resistances are connected in series, means 40. Okay, this is the and current in series, and current flowing through the circuit this is a 5 ampere. Means, can you tell me what is the battery voltage? How much is the battery voltage? 5 into 40. V is equal to I into R. 5 into 40 is 200 volts is a battery. Now, what will be the current if all these 4 resistors are connected in parallel? Means you got 10 ohm resistances of 4 such resistances are in series. Then this is what the circuit. Now what happened is, when all the 4 resistances, each of 10 ohm, are connected in parallel, then the resultant resistance will be how much, tell me? Then the resultant resistance will be 10 by 4, which is 2.5 ohm. but the battery is as it is, which is 200 volt. So I is equal to 200 by 2.5, which is none of the above. No, which is option B, which is 80 amp. Okay, are you clear? Give it a thumbs up quickly. Give it a thumbs up quickly if you are clear. Then I will move to the next question. Give it a thumbs up. Great. Your next question is ready. Go ahead. It's very quick. It's very easy one. You can answer it very easily. Yeah. But I think you will be trapped in answering this. Okay. Might be. I'm not pretty sure. Let's see how many of you are going to answer this correctly. And again, if you're watching a rebroadcast, question number and answer. Answer the comment. Give it in the comment, your answer. I'll see. Yes, yes. B, C, B. Cool. Couple of answers we're getting. Henry. Expected. Somebody saying Henry. Maybe B. Okay, there is no such option called maybe B. Okay. Anyways, okay. Just Prithvi. Lock it. Lock out Prithvi. Prithvi Raj. 6 is B. Cool. Okay. We got just 20 seconds more. Ampere per Weber. Yes, absolutely true. Ampere per Weber is the answer. Ampere for current, I don't think you would do that mistake by marking A. A is definitely not true. Okay. And this is for inductance. This is for inductance. Suppose if you by chance, if you miss what is a unit for this reluctance, you can even make it out. You can even make it out. How do you make it out? We know reluctance S is analogous to resistance R. Resistance R in case of electrical circuit, and in case of a magnetic circuit, what is the letter next to R? What is the letter next to R? S. In case of magnetic circuit, S is the opposition. Okay. So in case of electric circuit, R is equal to voltage by current. Okay. So tell me, in case of magnetic circuit, S is equal to, which is reluctance, R is analogous to reluctance. Okay. Now here we take it as E, right? E, EMF or voltage you can call. So similarly here, S is equal to what? What is S is equal to? E, EMF, analogous to, in case of magnetic circuit, MMF. EMF is analogous to MMF. So EMF is represented with the letter E. MMF is represented with its next letter, which is F. Okay. And what is the unit of this F? Ampere turn. Ampere turn. And here, current in electric circuit and flux in the magnetic circuit, they are analogous. Flux means phi. Phi unit is Weber. So reluctance is equal to ampere turn per Weber. Answer is B for question number 6. Okay. So here, if you miss by any chance, you have to make it out. I'm not asking you to remember what is the unit. If you don't remember, you should be able to make it out very quickly. That's the objective here. Okay. I told you, if none of the above is there in the options, don't pick that. Most likely, that won't be the answer. If all of the above is there, most likely, that's going to be the answer. I'm moving to the next question with the timer running already. TikTok. This is going to be very interesting. This is going to be very interesting. I'm pretty sure most of you will do a mistake over here. Give it a shot. Give it a shot. Give it a shot. Let me go through the comments meanwhile. See, I'm not giving the questions here. I'm just PYQs. These are previous year questions. Okay. So it's not my own questions. If you want questions, you go to download the app. You will have there hell lot of questions. Thousands of questions. Thousands of questions you will have from the app. You will learn a lot. The different levels, topic wise, level wise questions are there. Just go I know people would do something wrong here. That's expected. That's expected. Guys, be careful. I told you to be careful, but yet the moment you got down, you're just going for the answer. You need to be careful. Why I'm saying you need to be careful? Why? Because it is very simple. You have something, this option C is making you to be careful. Because this is saying both A as well as B. Okay? Means we know magnetic flux unit is Weber. That's pretty sure. Okay? So Maxwell, we never use this Maxwell as a unit of flux. But yes, this is one of the units of magnetic flux. Okay, earlier they used to use these Maxwells. Okay, mean 1 mega lines of flux, 1 mega lines of flux, or we can call it as 10. What is a flux means? Magnetic flux means what? It's a magnetic lines of force. Okay, 10 power 6 lines of force when you have means 10 power 6 Maxwells we'll call that one as 10 power 6 Maxwells, which is equal to 10 milliweber. Okay, 10 power 1 mega lines of magnetic flux means what? It is just same to 10 milliwebers, which means 0.01 webers flux. Okay, so both are the unit of magnetic flux. So option C is the right answer. Okay, shall I move to the next question? Shall I move to the next question quickly? Give it a thumbs up. Give it a thumbs up, so that I'll quickly load to the next question. Yes, Mohan, you need to be careful. Yeah. Next question. It's an easy one again. It's an easy one again. We just got 2 more questions beyond this. Okay, for this session. I'll come up with more questions in the next session. Okay. Yeah, quickly answer this. Quickly answer this. Yeah. Yes. Prajapati. Okay, Subhadeep Ray super fast. Prajapati is okay, good. Chavadi is 100. Nice. Hey, very good. I think everybody is in good form very quickly within just half the time, very short time you answer correctly. Yeah, now, what is the total resistance if 5 resistors of 20 ohm each are connected in series? If you have resistors connected in series, it is n times of each resistance. If they are connected in parallel, the resistance value by n. Now tell me, there is one more point you should keep it in mind. If you have, careful here, of course, just to answer this question, so all are connected in series, 5 resistances of each 20, so 5 into 20 is 100. Absolutely true. So if this would have been parallel, then you will go for 20 by 5. That's true. But now something interesting is coming up. It's not just answering a question. Recollecting the concepts around the question is very important, right? So we'll go to that now. That's the point. So the point what I want to make here is, in case of series, suppose let me take 2 resistances are connected in series. R1, R2, 2 resistances are connected in series. Then the equivalent resistance will be greater than maximum value of R1 and R2. Because when you add 2 values, the result will be higher than the individual one. Suppose this is 5, this is 1. So the result will be definitely more than the highest of these 2. Okay, that is highest of 5, more than 5. That's what I mean. Okay, now this is not a bingo thing. Next thing is, when you have 2 resistances, R1, R2 are in parallel, then what is going to happen? Tell me. Then R equivalent will be less than minimum of R1, R2. Suppose if I have here 5 ohms, if I have here 1 ohm, then if 5 ohm, 1 ohm are connected in parallel, then the resultant or equivalent resistance will be less than the minimum of these two is what? 1. So it will be definitely less than 1 ohm. That's the point what I want to make. And again, one more thing. Let me just recall one more thing. When you have, suppose, a 10 ohms and 20 ohms there in parallel, you don't have to go for 10 into 20 by 10 plus 20, all this stuff. It is pretty simple. This is 2 times more. 10 and 20 means what? They are 2 times more. So take highest value is how much? 20 is the highest value out of these two. How many times more? 2 times more. So 2 plus 1 is the answer. When 20 and 10 are in parallel, so 20 by 2 plus 1 is answer. 20 by 3 is answer. Okay. Now tell me, what if 5 and 15 are in parallel? Then how do you quickly do it? Take 15, which is the highest. 3 times more. 3 plus 1 is 4. So 15 by 4 ohm is the resultant resistance. That's what the quick way of solving the question. Shall I move to the next question? Do you understand these surrounding concepts as well? That's what the point of these PYQs, not just answering the questions. Pulling up some more surrounding data. Okay? Yeah. Over to the next question. Timer is running. Timer is running. Timer is running. I hope you're getting the point what I want to make. Nice, good. Good. Again, if you want problematic questions, different variety of questions, not necessarily these the previous questions. If you want model papers also, everything, they're all available in the app. Just download the app. There are a lot of things happening in the app. You can take use of those happening things. Okay. Wow. I think most of the people are saying B, B, B. Some people are saying C. It's fine. Okay. Yeah. Let's look into this. When 3 resistors are connected in parallel and those values are not equal, that's the point. Okay. So I have a couple of resistances are connected in shunt or parallel. And most of the people will have a lot of confusion in understanding whether things are connected in series and parallel in some cases, not in simple cases. For all those complicated cases, how to know in a simplest possible way how to know whether they're in series or parallel, I have given a lot of easiest techniques are given. You just go to the download the app, you will get all those things. Okay. A lot of free videos. You just enjoy those free videos. You will understand all these series parallel concepts. Now, the moment you have here some voltage, it doesn't matter what's the value of resistance here, R1, R2, R3, it doesn't matter at all. They're in parallel. Voltage will be same across the parallel. Current is same through the circuit. Okay, in the series circuit. So current across the resistors will be the same. No. Current, anyways, current is not across, current flowing through. That's what I'm going to be. And current will be different. Current will be inversely proportional to the resistance. So this is absolutely wrong. So voltage across resistors is same. That's true. And again, once you got this, it's not MSQ, multiple select question. No, it is just MCQ. So I can just stop going. I can just mark simply this. Or if it is MSQ, just go for it. Give it a check. The voltage drop across the resistors is proportional to the resistance of each resistance. No, it is just the same. So wrong. Let's go to the last question of today's session. Are you all ready? Give it a thumbs up. KPTCL form when will come? The KPTCL form is over. Now, coming to this question. Exam date, Bindu Prashant. Exam date, कब था exam? कुछ idea? Anyways, we'll let you know about the exam date. I think exam date is not yet out, maybe. Okay. So once they will announce, we'll inform you. Nothing to worry about it. Prithvi is saying, is it current is increase in the case, in this case? What is that case? Which question you're talking about, Prithvi? Current increases? Current, if it is a ninth question, currently proportional to the resistance. I think now with this, you will better understand the things are. Our next releasing course, we're working on, actually my team is working on digital electronics. Let's see. But I'm not pretty sure about it. Yeah, that's what the plan. Yeah, we already got the answer. 6:4:3. Parvesh. Madhu Teja is saying C. Interesting. Check it once. Question number 9. Okay, question number 9. Case of current. Question number 9. Prithvi was saying, is it current is increases in this case? Current, I'm saying that inversely proportional. If resistance is less, current is more simple. Yes. Now, question number 10. Question number 10. Consider a circuit with 3 parallel branches connected across DC supply. Okay, 3 parallel branches, branch number 1, branch number 2, branch number 3, okay, are connected across a DC supply. Fine, double fine. Now, what it says, what is the ratio of branch currents? This is I1, I2, I3, okay. What is the ratio of I1, I2, I3 if you have branch resistances, the resistances of the branch in the ratio of, it's not 2 ohm, the ratio, okay. So let's take it as a factor is 1. So let me take it as it is 2 ohm, it is 3 ohm, it is 4 ohm for the sake of simplicity. Though this is not in ohm, okay, it's a ratio, but I'm taking 2 by 3 means what? Some R will be there. So this value I'm taking it as 1, okay, for the sake of proceeding quickly. So 2 ohm, 3 ohm, 4 ohm I'm considering, okay. Now, with this, tell me voltage is same. Come on, voltage is in parallel. Just now I said voltage across all these resistances will be same. So the current will be, tell me what is the current? I1, I2, I3 will be what? V by 2 ohms and same voltage by 3 ohms and same voltage by 4 ohms. That's it. Now V is in common in all the cases. We just cancel out this V. So you'll have 1, 1, 1. Now you have this 1 by 2 is to 1 by 3 is to 1 by 4. So just take the LCM and do all the math. You will be getting 6, 4, 3. Okay. So answer is it is 6:4:3. Answer is this. Numerical type question. That's it. That's it. That's it for today. That's it for today's session. Okay. So just share this session with your friends. Share this session with your friends. And I'll continue this session PYQs of different exams in the upcoming days as well. Okay. So do you have any questions to be asked regarding these questions what I discussed regarding these 10 questions, or maybe any other YouTube videos what we have done already? Okay, so if you have any questions based on that, you can just ask me. I'd love to clarify those questions if you have any. Otherwise, we'll rock and we'll end the session here tomorrow. What do you say? Any guidance? Parvesh is saying 27th March. Any guidance? Yeah, you can just come to the guidance app. You'll have a lot of free interview questions. There are some questions, interview questions also there. Okay, electrical essential concepts. The key concepts are given in the app. Just download the app automatically. The app will guide you through a lot of things. Okay. Okay, guys. Okay, thank you, Funny. Just download the app. Download the app. You'll get everything. Power factor in electrical, y cos at y naught sine. That's what. It's a simple thing. It's not power factor. Don't think that power factor means it is a cosine of angle between a voltage and current. That's not the correct definition of power factor. Okay. Power factor formula turns out to be cos phi in some cases, not in all cases. In some cases, power factor formula turns out to be like that. But actually, power factor is a factor of 2 powers. All those details are given in the app. Just go to the app, you'll understand. Next session, hopefully tomorrow. Hopefully tomorrow is the next session. Okay. And meanwhile, you just go to the app. I bought your videos. They're amazing. Okay. Yeah. You will love it. Yes, they're asking such easy questions. What can be done? Sometimes they'll ask difficult questions also. Yeah. Okay then. Catch you up in the next session.